Let's see. Go for it.
Hi, hello everyone. My name is Kevin Cao. I'm an assistant professor of art here, and I welcome you to McKendree University's 2021 Academic Excellence Day celebration. Today I'm sponsoring one of our fantastic art students, Summer Brooks, who is graduating this year with her degree in art and her interest in ceramic arts. She has been a fantastic student, and I encourage everyone to check out her art exhibition and her artist talk in conjunction with Academic Excellence Day. I'll be entering these in the links down below. Just as a quick kind of side notion here, if you could turn your video off, and if you can also keep your mute button kind of locked in and loaded, that would be really great. This presentation is being recorded so that in the future, if you're watching me from some time in the future here, just know that the links will probably likely still be available. Without any more introduction, Summer, feel free to take it away.
Okay, so let me get my screen up. So I will be presenting on my exploration through ceramic glazes. So this is my ceramic journal. So for my honors thesis presentation, I knew that I wanted to do something that involved clay. I kind of fell in love with it my sophomore year. And so my decision process was, if I wasn't gonna make a type of clay, maybe I wanted to focus on the finishes for my sculptural work. And so I decided that, in art, finishes are so important and they really put a piece together. And this is especially true with ceramic work. So I knew that a piece can go from being okayish to looking very amazing just by the glaze application. Um, but I needed to decide what glaze I was gonna make. This decision was decided through what type of color, what type of texture, the functionality of the glaze, and a website that was incredibly important to me throughout all my research was Glazes. And this was a website where everyone could host their own glaze recipes, uh, professionals and hobbyists alike. So before I really get into explaining all the experimentation I did with my three main glazes, I need to kind of explain what a glaze is. And also, another component to my glaze journal was my recipe book. And so I wanted to create a book that housed the three main recipes. And this recipe book evolved into being kind of like a journal, and where I jotted down the test and what a glaze was and the three main compounds of a glaze. And so I'll be presenting part of my presentation through my recipe book. And so, like I said, we need to know what a glaze is. So a glaze is a mixture of raw powdered materials. You mix it together through a recipe that you either created or found online. And this will get mixed with water, which then will be applied to your sculpture or any body of clay that has already gone through the first firing process. And this will melt into a glassy-like finish. And it will fuse to the cup, and this creates a functional item depending on the type of glaze you create. And so the three main components that are that comprise a glaze are flux, alumina, and silica. And these are so important in making a glaze because the perfect balance will create the perfect glaze for you. And so a flux lowers the melting point, and it needs both alumina and silica to melt. Alumina provides stability and increases the durability of the glaze, and it also controls the flow. So this is quite important if you want to change how something flows. And silica has a very high melting point, so it will increase the melting point of any glaze, but it also gives a very glassy like finish. And so when deciding what glazes I wanted to create, I knew I wanted one that was functional in which I can add colorants and maybe create into another type of glaze. And I also wanted one that was more specialty based. Now, specialty glazes are more decorative than functional. So they cannot be used for eating. They can't be used for pretty much anything else due to the clay material being exposed. So I wanted to create two glazes that would be specialty and one that would be functional. And oh, I don't know what happened with that. Sorry, my internet's a bit slow. Okay, fix that. All right. Um, is it up? Can you guys see it? Okay. So I needed to decide my firing range, and this meant what temperature my glazes would be, basically what temperature range my glazes would be in. And I chose a clay type earthenware low fire. And this clay type fuses at a very low temperature. And I chose this because I wanted my clay body to be very stable. And I didn't want any reactions, odd reactions to happen because of a higher temperature. And since the clay body, when it fired for the first time, is very white, it actually allows the colors that are placed onto the clay body to be very vibrant. And this was really important to me again because I'm creating sculptural work and I want the best color accuracy when I'm painting those colors. So low fire actually isn't too low of temperature. It's actually a range between 1800 degrees and 1900. And we call this in ceramics cone '04 to cone '06. And a cone is a unit of measurement that typically represents the temperature ranges that a kiln will go through. And this happens during a firing. So the testing that I was going to be doing on my low fire clay, I needed to create a bunch of test tiles, which were the test tiles were created in the clay body that I was going to primarily be using. And I did test through line blending and a bit of additive mixing. And my testing was comprised of me adding about 5 grams of a substance to maybe 50 grams, and I'll later explain the test that I did. So the clear glaze that I created, I had sourced a recipe from Glazes, and I knew I wanted this to be a functional glaze, like I said. And one thing that was really important was I wanted to be able to add colors onto this glaze. And if I really, really wanted to, I could use this in some more of my specialty glazes by adding other materials to it, which I did later on. So The first test I did comprised of me just painting 3 layers and brushing 3 layers onto a body of clay, and the results were perfectly fine, and I didn't have any issues with that. So I decided to move on because I had 2 other recipes that I wanted to create, and I knew I would be doing color testing later on. So the second glaze recipe that I created, this was actually made much further on in my experimentation, so I didn't have as much time to experiment with it. But it was a rather simple recipe, and I wanted a glaze that was runny and that I can control. And so through the illustrations here, you can see that I formed the glaze into little beads that I would place onto the cup, and this would run and create this runny beady effect. And so for the first test I did, it was the initial glaze test, just figuring out how the glaze worked, how the glaze would be fired. Um, and the first test, I knew I wanted something that was a little bit more runny and had a little bit more fluidity to it. And so through my second test, I had removed the bentonite and I had added about 20 grams of pigment to it. And this actually caused the glaze to not melt at all. And so this is my first initial test. As you can see, the glaze, like I said before, it was fine, but I wanted a bit more fluidity. And so this was my second test. And this actually was all on test tiles, and, I think I had put it on a cup, but they had fallen off, and they were no longer had a sheen to it, so I knew that I had messed up adding or removing the bentonite, and I went back through my recipe, and I realized that I had added silica because when you remove something in a glaze recipe, it's important to rebalance out the recipe. And so when I removed bentonite, I realized I added too much silica, which, like I said, it increases the melting point of the glaze. And so this glaze was no longer able to melt, and also it lost its sticking properties to the clay body itself. So I didn't have enough time to do another test on this glaze, but I can theorize that I would reset the glaze recipe and probably remove some of the bentonite and add in something like grizzly borate, which is a flux which helps the glaze be more fluid and melt. So we're going to move on to the next glaze. And this glaze was the final glaze that I had decided to make. And it was my longest experiment with testing glazes. And so I knew I wanted something that would be bubbly and that was similar to my gloop glaze, but actually I could paint it on and didn't have to roll it into little balls and stick onto my my forms. And the first test I did was my initial test, and I realized that I wanted to increase the Frit 3124, which would help increase the roundness because my initial test, I didn't like how the glaze cracked. The crackle wasn't in the formation of what I wanted it to be. And by adding this frit to my glaze in 5-gram increments up to 25 to a base glaze base container of 50 grams, this actually didn't change much of my glaze at all. It allowed my glaze to stick and adhere better to its form, but overall, it didn't change much. And so at this point, I realized that maybe I should try an alternative to creating a bead glaze because there's this bead glaze is actually called crawling, and this is an undesirable effect in some glazes, and some materials cause the glaze to exhibit this crawling effect. And so um, the materials that do uh, cause crawling are called zinc oxide, manganese carbonate, and nepheline cyanide. And so I read an article that if I add 50% or 50 grams, sorry, 50 grams of whatever base glaze I had, the nepheline cyanide to the base glaze, this would cause the crawling effect, and each raw material would cause a different kind of crawling to it. And so I had added that, the three main ingredients, and my results varied depending on what had happened. So as you can see, these are the different tests, and in the upper left-hand corner, those are actually my initial bead glazes with the frit, and they all crackled, but they did not crackle in the way I wanted it to. And then on the right are my different tests with um, the three raw ingredients. And so this first one was manganese carbonate, and I had added 50 grams to about 50 grams of glaze. It did not melt at all, and it was kind of a hazard because it would flake off and it would still be very powdery. So the glaze did not fuse to the clay body, nor did it fuse to itself. So I knew that this did not work at all, and I probably increased the melting point of the glaze too high to where that the low fire range would not work. And so these were the tests that I did with the NEFSI and the zinc oxide. So from the left, this is NEFSI added to my base clear. Again, like I said earlier, my clear, could use it as a testing agent for these raw materials. So while the cracks were bigger and they were more attractive to me, I still wanted that roundness, and the this second test tile that you see is actually a commercial glaze that I had added NEFSI to kind of see if a commercial glaze can create the same bead effect. While it didn't happen in this tile, I had success where the cracks were bigger when I applied a lot of um, NEFSI, so over 50 grams. And this next one is to the right is clear with zinc oxide. Now the test tile broke off, so it was really the glaze broke off from the test tile. So the glaze is very brittle, but the cracks were big, and that was something that I liked. And on the bottom to the right, that's stroke and coat with zinc oxide as well, above 50 grams, added to 50 grams. And it broke off, but the cracks were, there was some interesting cracks again, but they weren't smooth. And so I also thought that maybe adding a clear coat over the stroke and coat commercial glaze would cause it to be a little bit smoother, but this did not happen, and the glazes didn't really fuse together and melt properly. So at this point, I knew maybe I should try something else. And this is where I conducted this test. So I took a commercial low fire clear glaze, and I took my clear glaze that I had made, and I had placed a layer under the bead glaze. And so from the left, this is low fire commercial clear um, under my bead glaze, and it caused the cracking to be a lot smoother. This is my clear glaze. The next tile over is my clear glaze um, under my bead glaze. The next one is my clear actually mixed in with the bead, which caused a very smooth effect to happen. The next one is the low fire commercial glaze under my clear glaze, and then I had put my bead glaze over that. And I had, in the next one, done a layering of the my clear glaze, and it also caused it to be a lot smoother. And then the very last one is a combination of layers between the low fire commercial and the clear glaze, which was similar to the third test tile that you see. I actually really enjoyed this third test tile, and this will probably going forward be how I create my bead glazes through mixing my clear glaze with the bead glaze. And so here is my final test that I had conducted of the glazes, of the bead glaze, and this was actually my color test. Now, the color testing um, was rather simple. I had took a scale and I had weighed on one side 5 grams, and the other side was going to be 5 grams of the pigment that I would add to the glaze. And so I had chosen a dusty pink, a more magenta darker pink, a very vibrant blue, of lavender, and a black. And so because the bead glaze is very opaque and it's white, all the glazes were rather dulled. So the first dusty pink, it cracked a lot and it actually didn't really the colors weren't really there. And for the second pink glaze that I had tried, the colors were also pretty much dulled, and I had to add a lot of the color in order to get it to show up. And this is probably because um, pinks and reds and purples burn out at a higher, or sorry, pinks, reds, and purple burn out when you get to a very high temperature. And so um, the pinks weren't becoming as vibrant as I would like. However, the blue, it showed up perfectly fine, and I had liked the results of that. The lavender was more purpley, so the reds and the pigment had burned out, but it was overall something that I liked. And the black was also something that wasn't as vibrant, but overall, when adding it to the bead glaze, it was fine. And so here is a test that I had did on one of my vessels. This is my low fire clear that I had created, um, mixed in with my bead glaze. And so I quite enjoyed, although my bead glaze wasn't something that I had initially thought it would be, I had quite enjoyed the test results of the bead glaze when applied to one of my sculptural works or one of my cups, like you see here. And so finally, I'll talk about my color test that I had did, aside from the color test that I did on the bead glaze. So as you can see, like I said before, this is kind of the test setup that I had. In the back corner, you can see, back right corner, you can see some of the pigments that I used and the test tiles stacked on it. And I have some of the glaze in its raw powdery form. And I would just take one of the lids, place it on the other side and measure out 5 grams and add it to the raw powder and mix it with water, paint it on one tile, and then add another 5 grams to that batch that I had previously mixed. And I continued that on until about 20 grams. And that's how I got my color test for all the color ranges that I had done. And so this is my clear color test. This is my clear that I created. And while the color showed up very vibrant, there was some textural issues because I had added too much pigment. I had added about 20 grams of pigment, and I could probably add about maybe 10 to 15 and not get that weird textural effect. And so before I move on to questions, I just wanted to conclude my testing. So although my testing didn't come out exactly how I wanted it to be, I thoroughly enjoyed the process and I learned a lot about just mixing glazes in general. And this helped me to understand how I can achieve better results and the relationship that glazes, that the raw components in the glaze have with each other, especially with the glue glaze. I learned that I cannot just take out and add something like silica because it